All right, let's just jump right in. We have all been there, right? You're on a train, you try to connect to the Wi Fi, and you just get that dreaded spinning wheel. It's beyond frustrating. But have you ever stopped to think about what's actually going on behind the scenes? Well, today we're going to pull back the curtain on the surprisingly complex, hidden world of train connectivity.
I mean, it seems like it should be simple, doesn't it? But getting online on a train is a world away from connecting in your local coffee shop. See, a coffee shop, it stands still. A train is literally a metal box hurtling through an ever-changing landscape at hundreds of kilometers an hour. And that, as you're about to see, makes all the difference.
You know, if you were to design the worst possible place for a wireless signal, it would probably look a lot like a train. You're moving at incredible speeds, which means you're whipping past cell towers in just a matter of seconds. The environment is constantly changing. One minute you're in an open field, the next you're in a tunnel or a deep cutting. And on top of all that, the very structure of the train car is actively working against you. And here is problem number one. And it's a big one. It's a physics problem called the Faraday cage effect. Basically, the train's metal body acts like a shield, blocking radio waves from getting inside. And we're not talking about a small drop here. In some cases, it can slash the signal strength by over 99%. So even if there's a perfect 5G signal right outside your window, almost none of it is actually reaching your phone. So, getting a signal past that Faraday cage is the first hurdle. But the real hidden drama, the secret battle happening on every single train, isn't just about getting a signal in. It's about how the train manages two totally different worlds of data that are fighting for that one very fragile connection to the outside world.
And this lays out the fundamental conflict perfectly. On one side, you have the train's own operational needs. This is the train's nervous system, mission-critical stuff like signaling and train control. It needs absolute, rock-solid reliability, but it actually uses tiny amounts of data. And on the other side? Well, that's us. Hundreds of passengers all wanting to stream movies, join video calls, and browse the web, demanding huge amounts of bandwidth.
And let me tell you, there is absolutely no question which one of those gets priority. The train's safety systems will always win. A dropped Netflix stream is, an annoyance. A dropped signal to the train control system, that's a potential catastrophe. The stakes just couldn't be higher.
So just how high are we talking? Well, critical train systems are engineered to something called Safety Integrity Level 4, or SIL 4. Just look at that top row. That means they are designed to have a probability of a dangerous failure of less than 1 in 10,000. It's a system where failure, quite literally, is not an option.
So how on earth do you solve this puzzle? How do you serve the train's critical safety needs and our data-hungry demands all inside a metal box flying down a track? Well, the solution starts with a single, really clever piece of hardware, the train's master router. Okay, meet the unsung hero of your journey, the Train Access Terminal, or TAT. Just think of it as a super rugged, incredibly powerful router for the entire train. Instead of hundreds of individual phones all desperately trying and failing to connect to the outside world, the TAT does it once and does it for everyone. It works using what engineers call a two-hop solution, and it's brilliant. Hop 1. A set of powerful antennas on the roof outside the Faraday cage grab the best possible signal they can find. That signal is then piped inside directly to the TAT. Then comes Hop 2. The TAT takes that signal and creates a strong, stable, local Wi-Fi network that it beams throughout all the carriages for you and me to use. And this setup is just so much smarter. First, the roof antennas completely bypass the Faraday cage problem. Second, it reduces the absolute chaos of hundreds of phones trying to connect down to just one single managed connection. And some of the best systems can even bond signals from multiple cell carriers together to create a single, faster, more reliable connection for the whole train. It's incredibly clever. Okay, so the TAT has solved the problem inside the train. We have a nice, stable Wi-Fi network in the carriages, but that still leaves the biggest challenge of all. How does the TAT itself, on a train that's speeding through the countryside, maintain a stable connection to the internet?
Well, operators basically have three main plays here. The most common approach is to just use the public 4G and 5G networks, just like your phone does. If the train is going through a really remote area with no cell towers, they can switch over to a satellite link.
And for the absolute best performance, some high-speed lines are actually building their own dedicated private networks right along the tracks.
But here's the thing. The most advanced systems don't just pick one of these. A modern TAT is constantly scanning everything, 4G, 5G, satellite, any trackside Wi-Fi it can find, and it seamlessly and automatically switches to whatever's providing the best, most stable connection at that exact moment. It's all about using every tool in the toolbox. So, all this amazing tech brings us to the really exciting part, the future. Because just giving you better Wi-Fi is only the beginning. It's all part of a much bigger evolution toward what's called the fully networked train, where this level of connectivity is going to change, well, everything. You see, right now, all that critical safety-first data we talked about, the train's nervous system, it runs on its own special network called GSMR. It's the backbone of the European train control system. And while it is incredibly reliable, it's also based on old 2G mobile technology. It was built for sending tiny packets of essential data, not for big downloads. And that is the huge challenge looming on the horizon. The very technology that ensures trains can run safely across the entire continent is getting old. It's expected to become obsolete around 2030, and it just can't handle the data demands of the future. This is exactly why the industry is working so hard on its replacement, a new system based on modern tech, often called FRMCS or LTR. You can really see the whole story right here. We're moving from a past where everything was separate to our present where we have one network for safety and another for passengers. But the future is a single, unified, high-bandwidth system probably based on 5G that can handle everything. It'll have the insane reliability needed for train control while also delivering gigabit speeds to passengers. We're talking fast enough for every single person on board to stream in 4K at the same time. So the next time you're on a train and the Wi-Fi feels a bit sluggish, just remember everything that's going on behind the scenes. Remember that incredible hidden network, battling physics and balancing the absolute priority of safety just to get you that signal. And then think about this. What new possibilities for safety, for efficiency, and for our own experience could we unlock when every single train becomes a fully connected gigabit speed hub on the move?